So doctor wants to look at age versus good cholesterol. 17 patients measured all the stuff. Okay, so let's open it up into StatCrunch. So here we have a 36-year-old guy, HDL cholesterol of 59, 43-year-old guy, cholesterol level 52, etc. He draws a scatter diagram. So graph, scatter plot. We want the age as the X and the cholesterol measurement as the Y. Okay, so here's the scatter diagram. So what do you think? Do you think there is an obvious relationship or not? Do you see anything in there? Yeah, I agree with Marita. That kind of looks like Cheerios to me. Some kid threw the Cheerios on the floor and they just scattered all over. Right? Some of them are clumping together, some of them are rolling away. I don't see any clear pattern at all. Doesn't mean there isn't any. It just means that by eye we haven't identified one. So I would say there does not appear to be a relationship. Okay? Determine the least squares equation. So let's do the least squares equation. Stat, regression, simple linear, age for the X, cholesterol for the Y, and here's the equation. Slope is the number in front of the X to 3 decimals. That's negative 0.78. And the intercept is 48,407. And so all I did is I copied the parameters that were computed by StatCrunch. Check our answer. Are there any outliers or influential observations? In other words, are there any points that are far away from everything else? Well, to me, this is the only point that possibly is this point up here. Now, whether this is an outlier or not, well, that depends on your point of view, I guess. I probably would say it's okay. It's not an outlier. It's not that much higher than this point. So we don't care if it's left or right. We just care whether it's too far above the line or too far below the line. This point is about the same amount below as that point is above. So that's probably okay. It's probably not an outlier. There isn't a point that's so far off that it's distorting the line. So I would say no. Hey, for me, that's not far out. Okay, so, okay. We haven't done any formal analysis of outliers. There are tests for outliers. We've skipped all of that. And so the only thing we can do is to look at it by eye. And I'm trying to give you a little bit of a thinking of how a statistical analyst might look at it. Say that, well, I don't care that it's far on the right. I'm looking at how far I missed the number. I missed it by this much, up and down, but I missed this one by quite a bit too. And I missed this one by quite a bit too in the negative direction. So this miss wasn't that much bigger than the other misses. Okay, test whether a linear relationship exists, null and alternative. Null is always the slope equals 0. Here it doesn't say positive linear relationship or negative linear relationship. It just says linear relationship. That's a two-tailed. Slope is not 0. P-value. Let's go back to the previous StatCrunch page. P-value for the slope is here. to 3 decimals, 710. Okay, so is this going to be a reject or do not reject? A P of 0.710. 0.710, we wanted to compare that to alpha equals 0, 1. So 710 compared to 0, 1, it's definitely high, very high. So we're going to let it slide. It's going to be a do not reject. Okay, so the P is correct. So it's a do not reject because P is high. P is more than the alpha. P is high, let it slide. Okay, confidence interval for the slope. Let's just go back to StatCrunch. We did a hypothesis test. We know that StatCrunch does either one or the other, either a hypothesis test or a confidence interval. So we go back one and we check off confidence interval. So we want to perform a confidence interval, not perform a hypothesis test. Remember, we had this starting in week 3. Week 3, we just did confidence intervals. Week 4, we started doing hypothesis tests. And we've been always choosing between these two options. Okay, so compute. And now instead of a hypothesis test, we have a confidence interval for the slope. Here it is. The lower limit is negative. The upper limit is positive. So even if we didn't do the hypothesis test calculations, we know that this is going to be a do not reject because 0 is in between. 0 is inside the confidence limit, inside the confidence intervals. Remember from week 4, if 0 is inside the confidence intervals, that means it's believable that the slope equals 0. So 3 decimal places minus 519. Okay, the upper one is going to be positive, 362. So this is the range of believable slopes. It can be as low as minus a half. It can be as large as plus 0.3 something. And 0 is a believable value for the slope. Exactly, Marie. It includes 0. Continue. So we're flying through this problem. But you can see that different linear regression problems all follow the same general pattern. Start with data, look at scatter plots, do a null and alternative hypotheses, run the StatCrunch output, so either do a hypothesis test or a confidence interval or both. And then, okay, so for a 40, then do the interpretation. 42-year-old male patient, would using the least squares regression line be recommended? So here we have a model using age, and we have just decided that age is not a significant factor. Let me write this down. So this is problem 6. So here we have age is the X, the cholesterol is the Y. Our conclusion was age is not a factor. Age is not a factor. So the question part F here says, should we use the least squares regression line? And so this is a yes or no. What do you think? Should we use the least squares regression line? We just found that age is not a factor, so should we use the age? No. We just convinced ourselves that age was not a factor, so we should not use this person's age. So we should not, because the null hypothesis was not rejected. So age is not a factor is a believable conclusion, right? Slope equals 0. So if we can't use age, how would we do the estimate? So I think we talked a little bit about one of these last week. If the average height of 21-year-old guys is 5'10", and some random 21-year-old guy walked in the room, what would you guess his height to be? You would guess the average. Right? We don't have any other logical thing to do. So we would guess the average cholesterol level. So to do that, we think back to week 1, that's summary stats, and we want to compute the average HDL. And the average is 44.9 something, 44.94. So here's a case where we can use our math to compute the slope and intercept, but just because we can compute the slope and intercept doesn't mean that we need to use it. If the slope is not significant, then we should not use it.